So in this video we're going to find the quantile function for the Weibull distribution. Now in the previous video we found the cumulative distribution function to be this function here, 1 minus the exponential of the negative of x, which is the random variable, divided by beta to the power of alpha. And beta and alpha are parameters which are the shape and the scale factors for this cumulative distribution function. So that's what it's given us. Now, to find the quantile function, what we're looking for is a function in terms of QA, where A is the quantile in particular that we're looking for, and Q just stands for the quantile. So here A would be in between 0 and 1. So that's where A would be, and what we're looking for is to represent this function in terms of this. So it's almost an inverse function of this. Sometimes it's called the inverse cumulative function. So that's what we want to try and do. So for this function here, what we do is, let's just write our f function here. I'll just write it in terms of f of x. So we've got 1 minus the exponential of the negative of x over beta to the power of alpha. So now what we do is, our setup is to find the quantile function. Wherever the x is, we put QA and we set it to equal a. And the idea is to solve it for QA. So our setup for the quantile function, so if I just write here quantile function, what we do is now we just set this to be a. So we put this variable in here. And then we set that to be 1 minus e to the negative. So x, we're plugging QA, which is the quantile of a. So for example, if it's the median, we want q of 0.5. That's the median, for example. So QA divided by beta to the power of alpha. So what we're going to try and do is try and get this QA out of this function on its own. And then we've got our quantile function. So as you can see, it's not too straightforward here, but it's definitely possible with algebra that we know. So let's get this exponential bit over to this side and leave the 1 here and bring the a over. So let's do that. So we'll have 1 minus the a, so that takes care of that. And then this minus, if we're going to add that to both sides to get this side to disappear, we'll get a positive version over this side. So e to the minus QA over beta to the power of alpha. Okay, now we've got a negative in our exponent here, and this here is just one function here, 1 minus a. So what we could do is we could take the reciprocal of both sides. So this here would be the equivalent of 1 over e to the QA over beta to the power of alpha. That's the equivalent of that. And then this one here, we'll just leave it as that. So that is the equivalent statement of that one. So now if I could take the reciprocal of both sides, I can just flip both sides. So now I've got e to the QA, so the quantile under beta to alpha, and then this time I've got 1 over 1 minus a. So I'll just write that like that. Okay, so now what I can do is I can take the log on both sides. If I take the natural log, obviously natural log of this, we know what that is. The natural log of this, that will get rid of our exponential and we'll bring the alpha out to the front. So by doing that, so if I just put ln of the whole thing. Okay, so let's just take the natural log on both sides. So now I'll have q, or quantile, over beta to the power of alpha equals now the natural log of this side. So now I've got the natural log of 1 over 1 minus a. Okay, now I've still got my alpha variable in here. So I need to try and get this out. So to do that, I need to take the natural log on both sides again, and that way then that will bring my alpha to this side. So let's do that. So now taking the natural log again of all of this, I will now have alpha natural log of QA over beta. So that takes care of that. And then this time we'll have the natural log of 1 over 1 minus A. So that looks like a bit of a handful there to take care of. Okay, now this alpha here I can now bring over to this side. So if I divide both sides by alpha, I can just take this one out and put this one in here. So that will take care of dividing everything by alpha. So now I've got the natural log of Q, my quantile, divided by beta equals 1 over alpha, natural log of all of this. Okay, now what I need to do is just try and take the exponential on both sides. So now if I just do this, take the exponential on both sides, that will get the exponential and the natural log to disappear, and I'll be left with my quantile function over b. So let's take this off the board and bring this up to the top. Okay, so exponential of all of this will just disappear, just leave me with my quantile over beta. So now I've got QA over beta. And then the exponential on this side, this natural log will disappear, but my 1 over alpha will now become in the power. So now I will have the natural log of 1 over 1 minus A, and then that's to the 1 over alpha. So that's the alpha root basically. Okay, so now what I need to do now, multiply both sides by beta, and I've got my quantile function. So now my quantile function with parameter A is beta times the natural log of 1 over 1 minus A, and then that's all to the power of 1 over alpha. So that's my quantile function that I need. So now all I can do now is just, for my median for example, so that would be my Q of 0.5, I just plug in 0.5 for my A. So that equals beta times the natural log of 1 over 1 minus a half, and that's the power of 1 over alpha. So 1 over 1 minus half, that's 1 over a half, so that's just natural log of 2. So then that equals beta times natural log of 2 to the power of 1 over alpha. Now for example, in the case where beta equals 1, for example, and alpha equals 1, my quantile would just become natural log. Okay, so that is my quantile function for my Weibull distribution. Okay.